How's it going, everybody? In this video, we are going to take a look at OSPF with authentication. And once we get through authentication and we move once we get through all the different types of authentication, then we're going to move into the other more advanced features like summarization and stub routing and all the cool stuff that makes OSPF OSPF. So, there is support for adjacency authentication to protect the control plane. There's a couple types of authentication for OSPF. There is adjacency authentication, which is going to be per link. So you're going to authenticate the adjacency between two routers. Then you have the area-based authentication. The area-based authentication is going to use the same methodology as the link-based authentication, except for you're going to configure the authentication at the area level, and then on the interface that connects you to the area, you're going to place authentication on those links. Now, typically, this is done where a group of routers connects to a common subnet. So in this case, you would do it on the connection between routers 1, 2, and 4 that connect to the switch, and that's where you would do your configuration. Now, you can do it when you have it set up for configuration where routers 2, 3, 4, and 5 all connect. You could do it there as well. The drawback to it is you're doing authentication on a per link basis. It's up to you on how you want to do it. Just keep in mind that when you do it at the area level, you have to go in and apply it to every interface that connects to that area. Now, the nice thing about doing it at the area level, this is automatically going to take effect when another router joins the area. So, for every additional router, or I should say any additional Layer 3 device capable of running OSPF joins the area, whether it's a firewall, a router, a switch, access point, whatever the case might be, if they support OSPF area-based authentication configuration, they need to be able to authenticate and make sure that they have the right type of authentication available. Now, with that being said, that's the high-level overview. Now, when we actually dig into the details, OSPF only supports packet header authentication by default. Now, what that means is the hello, hello protocol. So the hellos that go back and forth between two routers to make sure the adjacency stays up. The link state updates and link state requests. Those are the only ones that are in the OSPF packet header that support authentication. Now, that is only for OSPF version 2, though. OSPF version 3 takes it a step farther. Now, one of the things that I have to make clear, and especially when I teach live class in person, people tend to think that authentication means encryption, and it does not mean encryption. Authentication means you are telling or providing a credential to another router or the rest of the area that you belong there. So it's your way of the way to look at it would be if you were to have a key card to gain access to a building that you work at. So you do your proximity badge up to the card reader, it reads it, it looks back, makes sure you're authenticated, and the door pops open, or I should say the lock comes open, and then you're able to open the door. If somebody else comes in there and they aren't authenticated to enter that door, they're going to be denied. So the same thing applies regardless of where you go. Now with OSPF v3, and this only applies for IPv6. It does not apply for OSPF version or IPv4. There's a lot of limitations in OSPF v3 that we'll find as we get into it. A lot of the stuff carries over. Same thing with EIGRP. A lot of the same the bulk of the IPv4 functionality carries over into IPv6. So there's not going to be a lot of when I get to the IPv6 piece of EIGRP and RIP and OSPF and BGP, a lot of those same characteristics from v4 carry over to v6. One of the ones that does not, though, is encryption, where you can do both advanced level authentication using SHA-256, AES encryption, or SHA authentication, and AES encryption. SHA authentication and AES encryption. I had to make sure I said that right because there's two completely different situations. SHA is a hashing algorithm used to authenticate, and you have AES as an encryption standard, advanced encryption standard. So ESP is encryption, AH is authentication header. ESP stands for encapsulating security payload, which means that you're going to be encrypting the data. So with IPv6, you can actually do one-hop IPsec tunnels between your adjacencies, and that encrypts everything, not just the payload. So, or not just the headers, this is just authenticate the headers. So if you were to do a Wireshark capture and authenticate, you would see the authentication going back and forth, whether it's clear text or MD5 SHA. You can go in there and you'd see that. Now, I wouldn't recommend doing that, because then when you're dealing with the authentication piece, you're still going to see all the behind the scenes stuff. So you're going to see the link state advertisements and stuff like that being they're authenticated, but they're still clear text. You still see them. So you theoretically could sniff the traffic to see what's going on in the environment. Same thing with RIP, same thing with the EIGRP. You can still see what's going on in the environment. It's just the packet headers are authenticated. So there are 3 types of authentication that are supported with OSPF. You have type 0, I should say, which is null or no authentication. We have type 1, which is clear text or simple password. So a simple password is going to be, Cisco, and you'll literally see the password go across the wire. And then you have MD5 or SHA. So Message Digest 5 or SHA. Both MD5 and SHA are both hashing algorithms. Anytime you see a hash, that is 99% of the time going to mean authentication. There are some things where there's some encryption used with that, but that's typically not the case with encryption. Typically, you're going to see hash is going to be an authentication piece. So if you see type 1, that's clear text. Type 2, there's 2 variations of type 2, MD5 and SHA. We'll take a look at how that works later on. And we won't be able to test all of our functionality out, because of the iOS code that I'm running doesn't support every detail that's out there. Some of the advanced authentication in OSPF, especially OSPF version 3, doesn't support things like SHA-256, at least with the level of code that I'm running. So there's going to be some things that we won't be able to do and some things we will be able to do. Now, you can enable authentication at the process level, so the area level. You can do it at the link level, and now the link level overrides the process level, and the key is always applied at the link level. So yes, you can use a key to authenticate OSPF, and there's multiple ways of handling that. Now, the lowest active key is used, just like in EIGRP. And it can be enabled, if enabled underneath at the process level, process all links in the process are authenticated, and if enabled at the interface, only that link gets it. So if you go in there and type in IP OSPF authentication, or whatever the command is, off the top of my head I don't remember, you're going to do a per link, and you have to do it all links in the area or on a per link basis if you're doing it simply on that. Now, virtual links also support authentication as well, but authentication comes from area 0, so you would have to go to the interface to apply it to it. So you type in area 2345 virtual link authentication, and then you'd be able to apply it there. So then what you'd have to do at that point is, because a virtual link is a demand circuit and it does flooding reduction, what that means is there's no hello. So your authentication would work up until your if you don't clear it, nothing. It'll when you set up the authentication on a virtual link, everything will stay in place. And the reason for that is because of the fact that no hellos are being sent. You have to bounce the interface, so do a clear process or bounce the interface in order to get that to trigger. By doing that, you're going to send a link state update, which is going to trigger the authentication, and it has to be done on both sides. So you do it on one side, then you have to do it on the other, because authentication is bidirectional. So the way the crypto works, and I'm going to break this down for you so that we have an idea of how this actually gets deployed. You have I have a password and I run a hashing algorithm and get the results. I do the same thing on the remote side. I send my hash to you and you compare it to yours. If they match, then the adjacency forms. If they don't form the adjacency. Now, if you're looking for a reference in the RFC, it's in 4.3, and this is going to be 2328 is the RFC number for OSPF version 2. You can also do automatic key rotation, so you can do time-based authentication if you want to, just like EIGRP does. And you have to apply a keychain, and then you have to make sure that you have the time set up and stuff like that, because you can use you set up a keychain to assign the key and all that type of stuff. It does work out. I've never used it with OSPF, just like I didn't show you guys how to do it in EIGRP. It's an advanced capability, but beyond that, just be familiar with the capability of being there and just modifying the keychain send and accept lifetime values, and that's all you really have to worry about. Now, the different types of authentication we're going to get into as we get along. It actually gets kind of interesting as we go along. So, with null authentication, by default, this is the authentication, or no authentication. If you were to do a debug, you would see type 0 authentication. Now, clear text authentication, with the clear text authentication, the password is sent clear text in the IP header of every packet, so you can sniff and see the password. It's not recommended to use this, and the only reason you would use this is for older iOS images that don't support newer features, and that's literally all you would use it for. I've never used clear text authentication in production. I did have a client once that had a clear text authentication. They wanted to authenticate, but the only one they would be able to support on the older code, and I think they were on 11 something. It's been like a year and a half since I've been dealt with them, but I believe they had 11.1 or 11.2 code is what they were running, and on a 1700 series router. And I recommended to them to upgrade to an 1841. At the time was one of the best sellers, an ISRG one, and we got the box. I made some. We shipped it to the location I was working at. I configured it, mailed it to them, and then they literally was just plug it in, and it worked. I mean, the authentication came right up. But that falls back to me knowing what I'm doing. So you get MD5 authentication is type 2, and it's a cryptographic algorithm, and it comes out with some really weird hashing algorithm that it runs through. And I'm not a math guy, and I'm not a security guy, so beyond that, there's really I don't get into the math on that type of stuff. I just know how it works. So, and then we have multiple keys with MD5, and this would support after automatic key rotation. Again, I've never used this, but the main factor that I want you to take away from doing multiple keys with MD5 is if you're going to choose to do that. Let's say you want to lab it up, you want to test the feature out. Excuse me. If you choose to do so, you have got to be careful with your send and accept lifetime values, because if your send and accept lifetime values are too close to the next one being sent, which means either NTP or PTP, Network Time Protocol, or Persistent Time Protocol, if any of your timekeeping mechanisms are off and your clocks are off on your two different devices and you're trying to authenticate with another one, somebody else, the connection will go down if your clocks aren't synced and your send and accept lifetime values are not overlapping enough. Typically, I go 12 hours of overlap. That's just a general practice for me, because this way here gives a 12-hour window on the same day. It's usually on a Sunday when no one's there, so that if anything does go down, it's not performance impacting. And typically Sunday evening about 7 p.m. And then if anything does happen, I've got until literally like 8 o'clock the following morning to get it fixed. So if it does break, and then again, I've never actually used it. I've never had a reason to. If a client needs authentication, they set it and they forget it and they go away. If they need to make a change, they'll re-authenticate down the road. And I've never seen a client use area-based authentication. I've seen them only use link-based authentication when they're adding a new router. And that's the only time, or they're replacing a router. That is it. So in addition to what you have with MD5, you have SHA. Now SHA is a little more complicated than MD5. It's a little harder to crack because it takes more into play. Now with MD5, you're dealing with, I believe, it's 128 bits. So MD5 at its biggest is 128 bits, and that's how big it is out of the gate. And depending on which RFC you're running with OSPF, you could get, typically it's only using half of the actual total output size, so 64 bits. That's typically all it's doing. All the extra stuff is padding and additional features, but it depends on which version of code you're running and exactly how it does its job. Now SHA, it's a little bit different. SHA out of the gate uses 128 bits. So we have SHA 1, 160 bytes, right? Because I believe it's SHA 1. Let me just look that up real quick. SHA 1. Yeah, SHA 1 is... It says it right there, actually. 160 bits of digest. Let's see. Yeah. Oh, actually, to be honest with you, no one's telling me what it is. I'm actually on my other monitor looking up the details because I wasn't quite sure. Bit size. Yeah, it's 100. It's either 128 or 160, depending on. That's Wikipedia. But we're gonna run with SHA 1 is 160 bit, and go with that because that makes the most sense. So SHA 1's 160 bits. You have SHA 256, which is 256 bits, and obviously, you know, if you go 384, it's 384, so on and so forth. So SHA, it's a bit bigger, it's a bit beefier, a little bit harder to crack. And depending on the code you're running, you may or may not be able to run SHA authentication. So we'll take a look at that, and I'm not sure if we're going to be able to run that or not, but we'll take a look when we get into it. So a couple of the pitfalls for authentication, especially when you're dealing with virtual links, is it's in area 0, and you have to make sure that you're authenticating it for that. And mismatch in authentication can break you, so it's either a mismatch authentication type or the authentication key. So that's typically the problem you're going to run into. So now that we've discussed on how authentication works, we're going to take a look at this on the CLI. We're going to take a look at doing clear text, MD5, and area-based. So what we're going to do is on the CLI, we're going to go and, like I said, disregard that. The first one we're going to take a look at is between router 3 and 5 on area 0. So we'll go to router 3. And what we're going to do is we're going to go to global config, and we're going to type in interface fast 1/1 and type in IP OSPF and question mark. You'll see at the top here, let me bring this up a little bit, that you have authentication. So you type in authentication question mark, and then you have to space it out and you go authentication, and we're going to use message digest. Now, this is actually, if you were to hit the enter key right here, this is clear text. Because I could type in message digest, and that would be the mode essentially. So if we type in message digest, and then that would be telling you and I that that is to set up MD5. But I want to do clear text out of the gate. So we're going to hit authentication and hit enter. Then what I need to do here is I need to hit the up arrow, take a step back, and type in the dash, tab key, and then do question mark, and then what's the password? So I'm going to type the password is going to be Cisco, question mark. And now, actually, I want to take a step back. A white space, like this one right here, just like in the EIGRP and the keychain, is valid. So we're going to hit the enter key, type in do show run interface fast 1/1. So we've turned on authentication, and the password is Cisco. We're going to go to router 5. I'm going to do jump out of here, and if you see the dead timer expired, we're going to do a debug IP OSPF packet and hello, and hit enter. Now what we're going to do is we're going to go to the go up here, And what we're going to do is we're going to type in interface fast 1/0. We're going to type in IP OSPF Authentication, and then key is going to be Cisco. Okay, we're going to send that back and forth, and then you'll see that authentication type 1. Let me actually bring this over just a little bit. You'll see authentication type 1 right there. Actually, let me do a do you all. Now, once it stops, now let me point something out to you. Right here, we can tell it's authentication because we see AUT is 1 right there. Now, if you come down and you go to the link between 17, and this is router 5, or 4, notice authentication type 0. So that indicates to you and I that we're not doing any authentication at all. So that's how you would do clear text. Now, between 2 and 3, we're going to do MD5. Go back over to 3. We're going to type in interface fast 1/0 and type in that. We're going to type in IP authentication. I'm sorry, here, type in OSPF authentication. Now, what we're going to do here is we have to do this. Now, if you come down to message digest, this is going to be turning on MD5. So we're going to type in message digest. We got to hit question mark and hit enter. Now, what we're going to do is we're going to back this up a couple here, and we're going to type in IP OSPF, and then right here, message digest key. That is going to let us configure the key for message digest. Question mark, and then the key ID is going to be 1, and then we're going to do space MD5 and question mark, and then we're going to type in the password. So we're going to type in Cisco. Okay. Now we're going to go to the other side, and that's actually going to take us down. And now that's the directly connected link. That's not the virtual link. That's just the link between 2 and 3. And now we went down because of the fact that the dead timer expired. We go to router 2, and I got to get myself a new mouse. I'm going to do a debug IP OSPF hello and packet. So you're going to see that we're receiving hellos from 4. And now we're going to go to global config. We're going to type in interface fast 1/0. Type in IP OSPF authentication is message digest. And then we're going to type in message digest key is going to be key ID 1. And we need to use MD5. And then the password is going to be Cisco. We're going to send it back and forth. We have a key ID of 1. And if we type in do you all, you'll see that right here it says authentication type 2 right here. Authentication type 2 with the key ID of 1. So that's how we're authenticating. And this is an MD5 digest. Okay, so that takes care of that problem. So it's, and then the virtual link comes back up because of the fact that our peering is now back together. Now, since we're here, we're also going to do the what do you call it? We're going to do the virtual link. So let's go to router OSPF2. We're going to type in area 2345 question mark virtual link, and we're going to type in authentication and message digest, virtual link. We're going to type in actually, let me do this. Do show run pipe section OSPF. Because I forgot the address that I appeared with him on, and then it'll tell me right here. So this guy right here, we'll type in this guy right here, right click and paste that in, question mark, and then we have authentication, or we can do clear text, or we can do, this is clear text, remember that, or we can do MD5. So we're going to type in authentication, question mark, we're going to say message digest, question mark, and we're going to say enter. We're going to hit the enter key. And then what we have to do is we have to take a step back here, and we're going to say the message digest key 1 is going to be MD5, and we're going to say Cisco. Now we type in do show run pipe section OSPF, and I'm actually just going to copy and paste this over on the other side. It'll make it easier. And we're going to have this set up here. So we have the virtual link is being authenticated now. So we have that situation ready to go. So I'm going to go to router 3 now, and now the virtual link. Now notice how nothing bounced. Okay. Now if we were to bounce it and type in go to interface fast1/0 or clear the process, the virtual link would stay down because only router 2 side is authenticated. So let's do this. We'll type in do clear IP OSPF process, hit and yes. We're going to bounce the neighbors. You'll see everything comes back up except for the virtual link. And the reason for that is because of the fact that we don't have authentication on the router 3 side for the virtual link. So now it says folded down. Notice how everything came up, but except for the virtual link. So do show IP OSPF interface brief. The virtual link right now, BL1, is down. Nothing's there. It is not operational. If there was, we would see neighbors would have a 1 of 1. So that's our indication that something's wrong. We're going to go over to router 3 now, and we're going to go to router OSPF 3, do show run pipe section OSPF, so we get the correct information here. And then we have our virtual link, so we're going to type this guy right here. I'm going to do question mark. We're going to do authentication is message digest, and we're going to hit enter. And you can, yeah, there's a question, so you can adjust the hello and dead interval. Yeah, it's just like any other type of connection, and you can even do TTL security on this to make sure that it's not being spoofed by somebody else. So we're going to come over here and type in message digest key, and the key ID is 1, and the password MD5, and the password is Cisco, and hit enter. And now that we've done that, what do you think is going to happen? Well, it's going to come back up. So we're going to type in do show IP OSPF interface brief, and you can see right here on the point-to-point link for the virtual link, we have a connection to 23.3 on this connection right here, and we have one neighbor. We go to router 2, we hit the up arrow, and now we have one link. Notice how it changed. Now we have a appearing there. Everybody's happy. Now what we're going to do is we're going to take a look at. I'm going to actually bounce out of here, and I'm going to type in keychain, and we're going to say test. I just want to see if what's available. Key 1, and I'm going to type in. Yeah, see all your advanced stuff, key string. All that advanced stuff isn't here, so we can't even do the advanced configuration for the crypto, because it would say cryptographic algorithm underneath here if it was there, and it doesn't show up. So cryptographic algorithm, we're not even going to be able to do SHA authentication if we wanted to, because the configuration is not here. So give me 1 second though. I wanted to show you the actual syntax of this. So what I did is I fired up one of my CSRs in my virtual environment that I'm running in ESXi, and it's in the process of going through the boot up right now. So I'm going to take you guys back over to get area-based authentication, and then I'll get this puppy situated. So we're going to take a look back now here, and what we're going to do is on router 2, 1, and 4, I'm actually going to exit out of Keychain because the commands are I think I'm going to. I honestly don't know when it came out. I think it was 15.4 code, and I'm running 15.2 code. So do show ver pipe include iOS. I'm using 15.2.4 for the service provider train. So what I'm going to do is I'm going to go to router OSPF 2. I'm going to type in area 123 question mark. I'm going to type in authentication is message digest. I'm going to hit enter. Now I've just set up area-based authentication. Now what I need to do is I need to exit out of here and type in interface fast2/0. I need to type in and actually the CSR is actually booting up right now, as you can see. So I'm gonna leave that boot up right there. I'm gonna let him roll with that. And I just have a console session set up to my ESXi server. So I'm gonna type in IP OSPF Authentication is, and now the neighbor goes down. Authentication, message digest key, OSPF message digest key is going to be key ID 1 and then MD5, and then we're going to type in Cisco. Okay, now you have to repeat this process on router 1. We're going to go to router 1, type in router OSPF 123. We're going to type in area 123 authentication message digest. We're going to go to interface fast 1/0 and type in IP OSPF authentication is message digest message digest key is key 1 MD5, and we're going to say Cisco. Now by typing that in, we should form the adjacency again. And there we go. Now we're going to go over to router 4. I'm going to type in, since we're under router configuration mode, I'm going to type in area 123 authentication message digest. I'm going to go to interface fast 2/0 IP OSPF message digest key 1 MD5 Cisco. And so we should form our adjacency back with router 2 and 1. And it's as soon as a hello goes back and forth. And so we do have our authentication back up, and we have our connection to 2 back up, and now 1. So that's how that would work. So it's pretty straightforward for the most part. It's just understanding the point that you need to set this up with. So I wouldn't say it's very complicated at all. It's just you have to know what you're doing. That's the main thing. And if everything works out, then it should be pretty straightforward. So this guy's still booting. What I'm going to do is I'm going to just show you what the command would look like. I don't feel like waiting around for that thing to boot. Actually, it was in the process of installing itself. So if we give it a couple seconds here, we should be ready to go here momentarily. And unfortunately, you can't speed this process up. It's actually a pretty powerful box once you have them running. And at one point in time, I had 20 CSRs installed and running, and I was, but the drawback to it was all Ethernet based. And you get more than just Ethernet on the lab. So you get Ethernet serial, and so you don't have the luxury of just being on Ethernet boxes all day long. I had to switch over to GNS3 to do different things because, they're going to test you on everything in the lab, and you can't be, if you do just Ethernet, you're going to be selling yourself short. And there's not a lot of serial in the lab. There's some, but not a lot. I think I had, 4 connections? 5 connections maybe? No, I'm sorry, 6. There were 6 connections I had in the lab that were serial based, and they were all PPP. I don't think there was any HDLC. So, but anyway, obviously, I didn't walk away with a CCIE, so that should tell you how that came out. But it was a good experience. So I'm planning on taking it again very, very soon. So that's why I'm going through these videos, because it's actually a refresher course for me, which I don't really need it because for the majority of this stuff, I'm just talking off the top of my head because I know the stuff. But anyway, I'm not going to waste any more of your time. This is just clearly taking too much time to boot for me. So it does take a while. I'm not even sure this is installed, or if it did get installed. Oh, there it is. Oh, it's okay, there it goes right now. That's why that was the problem. So I'm going to type in no. I'm going to let it load up here. And I believe if I go back to here, yeah, see, it's still in the process of loading up. So actually what it does is it goes in, it installs itself, and then once it's installed, it reloads, and then it brings you to the operating system. So it's just like any virtual machine, like a Windows box or whatever. So now we should be just about there. So let me click inside of it. And building configuration, now we're at the router. So actually it's got a little bit more to do. So now we're here. We're going to go to enable. I'm going to type in config t. I'm going to type in keychain. Actually, let me do this. I'm going to do platform console serial, and then I'm going to do. So now what that allowed me to do here. Let me break off of that. Come over to the thing, bring this guy in here, and hit enter key in here. Okay, it's not gonna. Okay, I know what I got to do there. So I'm gonna pause the video real quick, and I will be right back with you. And there's a question: what do you got to do to get it working? Actually, what I got to do is I got to type in license boot level is premium. Yes, and that's going to let me boot to a different version of it. And then I have to write mem and reload. And let me make sure that I'm writing do show ver pipe include iOS and 15.4, right? Yeah, I'm using a base config 3.11. So now what I'm going to do is I'm going to step out of here. I'm going to write mem. It's going to build the configuration. I'm going to reload and confirm with reload. I'll pause the video to get that back up and running, and then as soon as the router starts booting off the console window, I'll bring it back in. Alright, so we're to the point now where we are going to boot off of the console window, and as you can see right here, we're going to get similar outputs. So it's running the hash on the back end for the SHA-1 to make sure that the thumbprint works out well, and then as soon as it does that, it'll start to load up. In case you've never seen a CSR 1000V boot up before, this is how it works. And basically, a CSR 1000V is a ASR 1004, I believe, but they've virtualized it into a virtual machine. So it's a virtual machine you can download. It's free to download. It's about 300 meg, I believe, is what they are. And now it's going to boot up to this guy. And if you were to look at my CCIE version 5 lab setup video, I walk you through how to set up the vSphere to allow this to work and set up the consoles. So it's actually pretty easy once you get it working. It just takes a moment or two for it to boot up, and once it does, it works out quite well. And there's a question: what are the resources per box? I usually give it one CPU, and by default it pulls in 2.5 gigs of RAM. So it is quite resource intensive, but you can get away with 2, and that's what I'm using here. And I've got half a dozen installed and ready to go. I just choose to not go that route, at least for right now. It was great for testing because it allowed me to play with a lot more configuration than I was actually going to see. And so here we are. We're at the boot menu. We're going to hit the enter key. I'm going to go to enable. I'm going to go to config t, keychain test, and then I'm going to do key 1 and question mark right here, cryptographic algorithm, question mark, and then you have your SHA authentication. And this is where you would type in SHA-1, MD5. So you can do it here, but you have to use I believe 15.4 code and above supports it. And actually, give me 1 second. So I'm booting up another 7200 from the computer I'm recording from, and this is running 15.3.3 code, and it's a little beefier than what I'm running in GNS3 currently, but so it's up now, so I'll be able to let me click inside of it. So go to global config and keychain test key 1, and okay, yeah, see here I'm in 15.3 code, and right before it went to 15.4, and cryptographic algorithm isn't in here. So if you want to use the capability of doing cryptographic algorithm for doing SHA authentication, you have to have 15.4 code and above. And now I'm running Advanced Enterprise Services here, so at any point in time, if I type in do show ver pipe include iOS, this K9 at the end here, that indicates that it's got the security features available to it. And right now, those capabilities aren't there. Now, if I wanted to go in here and say, for instance, I want to type in crypto ISACAMP policy 10, and I wanted to do the hash, it supports it. right? So, and the same thing with the CSRs here. Or I'm sorry, with these guys. If I wanted to exit out of here and type in crypto ISACAMP policy 10 and type in the hash, SHA is supported here, but that's only for phase 1 IPsec VPNs. Or I should say phase 1 ISACAMP. So that gives you the idea what you can do. So we're going to test this more out when we get into DMVPN, which is coming up down the road. But just so you're aware how this would work. So it does support it, but not for the authentication that we're looking for. So I just wanted to make sure you guys are aware of that, just in case you're trying to learn how to do something or play with it. That's how it all comes out to play, and go from there. So you got a little bit more in this video than you were probably banking on, but I think that was good to see how that would break out and go from there. So I hope this has been informative for you, and I just thank you for viewing.